Since the 90s of the last century, Gaza Strip has witnessed a set of strategic plans related to infrastructure, aspiring to improve the efficiency and effectiveness of environmental aspects, especially what's so related with water sectors. The frequent delay in enhancing the infrastructure project for many years has led to progressive environmental bad effects in Gaza Strip, like increasing the salinity of groundwater and seawater pollution. Khan-Younes governorate, which has more than 3,400 residents and located in the southern part of Gaza Strip, is not served by any comprehensive wastewater treatment plant. Most of the collected water is transported to the western temporary lagoons, where wastewater is discharged directly to the sea without real treatment. The project aims to construct an extendable and phased wastewater treatment plant with a flow capacity of 26,656 cubic meters per day for Phase 1 and 44,948 cubic meters per day for Phase 2. In order to achieve the project objectives, the following buildings are necessary to be constructed. Pre-treatment area. It is the first receiver of wastewater, aims to treat wastewater initially by extracting heavy and bulk solids. It is divided into two parts. Pre-treatment channel consists of coarse bar screen and fine bar screen and responsible to extract bulk and heavy solids away. Grit and grease removal channel to separate sand and grease away of wastewater and settling sand particles through channel stream. Distribution well number 1. By this well, water is transferred directly to the aeration tanks by 3 pipes, one for every tank and the third for future expansion. Aeration tank. It is the largest building in the plant, which will receive wastewater from pre-treatment area. It uses air diffusers and submersible mixers to accelerate and move internal air streams through the wastewater. It is considered as a curbstone due to its main task. activating bacteria by exudation process to feed an organic material. Blower room. It's an aeration-attached room, provides the aeration tank by required oxygen for the oxidation process. It consists of air blowers with VFD, variable frequency devices, that are linked with aeration diffusers by oxygen sensor to evaluate and control oxygen amount in the aeration tank. Distribution well number 2. By this well, wastewater is transferred from aeration tank to clarification area by 2 lines, 1 line for every 2 clarifiers. Clarification area. 4 basins with 4 suction scraper bridges that are used to separate between solid sludge and wastewater. This construction works also as a second stage of wastewater separation. The outputs of this clarification process are: pure grease is replaced by upper scammer and repumped back to pre-treatment area by scum pit. Semi-solid sludge will be pumped to a thickener construction by sludge pits. Semi-pure water is pumped to tertiary treatment construction, sand filter by distribution well 3. Degassing tank. It is the first part of clarification area, which will receive wastewater from aeration tank, makes primary water grease separation, and repump it to clarifier's tank. Distribution well number 3. By this well, semi-clean water produced by clarifiers will be transferred directly to the tertiary treatment construction sand filter. Sludge pits, the final part of clarification area, which will receive and collect semi-solid sludge from the lowest level of the 4 clarifiers, then repump it to the thickener's construction. Thickener's construction. 2 basins with 2 pickets fence are used to get the final sludge separation. So, the outputs of the thickening process are: pure sludge is pumped to drying beds by thickened sludge pump station. Surplus water is repumped back to the pre-treatment construction by backflow pump station. Tertiary treatment construction sand filter. It receives semi-clean water produced by clarifiers, which has been pumped by distribution well 3, and implementing financial purification using both systems. Sand filter system for purification, UV disinfection system. Drying bed. Here's the semi-solid sludge pumped from the two thickeners is spread to get the required hardness and filter the rest surplus water. Compositing area. In this area, the pure sludge is collected from the drying beds. Then it's mixed with some materials such as hay to convert it into natural composite. After that, it is distributed to farmers for agricultural use. It is the most important step in this project. After the step of reaching the clear water, since it protects the environment from sludge pumping to the sea with its environmental regional dangerous pollutants. Finally, we would like to thank all of who facilitate the coordination process of this project.